Standard 7.2 gets at calculating the future horizontal and vertical speeds and displacements of a projectile with no initial vertical velocity. We need to remember that the word displacement, right, is talking about the distance something travels in a general direction. So if the information that we have is that a marble rolls off a 1.3 meter table at a speed of 5 meters per second, we need to solve for the range, the horizontal speed when it hits the ground, and the vertical speed when it hits the ground. The very first thing that we do is need to separate our papers into X and Y. So I'll put X on this side, and I'm going to put Y over here. We also need to then remember what are the equations that we get to use on each side. On the X side, we only have one equation that we can use. V equals D over T. The first thing I'm going to do is list all my different variables for each equation. On the Y side, we can use D is equal to 1/2 AT squared, and I'll list all my variables. We can also use VF equals VI plus AT. Again, list all your variables. By listing your variables, you put yourself in a position to be able to determine what am I looking for and how can I solve for it. Now let's look at the information that we know. We know that we have a table that's 1.3 meters tall. That's a distance in the Y direction. So over here, I'm going to put 1.3 meters. We can also look at that same equation and know that acceleration is equal to negative 9.8 meters per second squared. So let's put that in here, negative 9.8 meters per second squared. This never changes, so I'm going to put that here too. Now that I've moved over to this other equation on the Y side, when something rolls off of a table or is launched horizontally, the only direction it's moving right away is horizontally, or in the X direction. That means my initial speed in the Y direction is 0 meters per second. Because as it rolls off, if you think back to vectors, it's rolling straight off. This means there's only an X component. There's no Y component until it started to get off the table a little bit. Now if we look back over onto our X side, we have 3 different letters there, or 3 different variables that we're looking for. We don't know the distance because that's the range, so this is what we're ultimately going to look for. We don't know a time, but we do know the speed at which the marble rolls off the table, 5 meters per second. Remember that when something rolls off a table or is launched horizontally, that horizontal speed, in our case 5 meters per second, never ever changes. Now, taking a look at this, if I'm going to solve for range, I first need time. If I look over on my Y side, I don't have time in either of those equations either. However, in this equation, it's my only missing variable, which means it's pretty easy for me to solve for. The reason I can solve for time on either side and then use it throughout the entire problem is that time doesn't matter if it's going X or Y. Time is going to continue to pass regardless of the direction in which you move in. So to solve for time, the first thing I see here is my equation. D is equal to 1/2 AT squared. The first thing I'm going to do is get rid of this 1/2 by multiplying by the reciprocal, 2 over 1. That cancels out these, and I get 2D equals AT squared. I'm going to divide each side by A now. 2D over A equals T squared. My next step is to take the square root of both of those. And I end up getting that the square root of 2D over A equals T. If I plug some numbers into this, I get 2 times a height of 1.3 meters all over 9.8 meters per second squared. That's going to be my T. Now I know that we put a negative 9.8 in up top here. The reason I'm not putting a negative 9.8 in is as I solve for time, I can't have a negative time. The other piece to remember is that you can't take the square root of a negative. So if you leave that in there, you're ultimately going to get an error on your calculator. 0.51 seconds is what you end up getting when you solve for that. I'm going to put that time in everywhere. Now it looks like over here I can solve for the range. By rearranging my equation and multiplying each side by t, I get TV equals d. T is 0.51 seconds times v, which is 5 meters per second, equals d. Solving for this distance, I get 2.55 meters in the x direction. That's my range. The other two things I need to solve for are a horizontal speed when it hits the ground and a vertical speed when it hits the ground. Well, I know that if it launched at 5 meters per second horizontally, that's never going to change. So I should have 5 meters per second as my horizontal speed when it hits the ground. The last thing that I'm solving for is my speed when it hits the ground vertically. That means I need to go back over to my y side. I'm going to section off a little bit of space here so that I can solve for it and not make it blend with my other work. If I use the equation VF equals VI plus AT, I'm ultimately solving for VF here. So VF is equal to my initial speed of 0 meters per second plus negative 9.8 meters per second squared times 0.51 seconds. When I do that math, I get a final speed of 4.9 meters per second. Remember that this is negative. Negative 4.9 meters per second. It makes sense that it's negative because it's going down.